Let's try to link our project with the C standard library. The C standard library which we are going to use is NewLib and NewLib Nano. Let's explore about the NewLib. NewLib is a C standard library implementation intended for use on embedded systems, and it is introduced by Cygnus Solutions, now Red Hat. NewLib is written as glibc replacement for embedded systems. It can be used with no OS systems, that is bare metal systems, or with a lightweight RTOS. NewLib ships with GNU ARM toolchain installation as the default C standard library. We have already installed this GNU ARM toolchain on our systems. That means we have already installed the NewLib library. I will show you that in a moment. glibc includes ISOC, POSIX, System5, and XPG interfaces. MicroLibc provides ISOC, POSIX, and System5 features, while NewLib provides only ISOC. That's the difference between NewLib, MicroLibc, and glibc. NewLib comes with less feature sets. Then how about NewLib Nano? Due to the increased feature set in NewLib, it has become too much bloated to use on the systems where the amount of memory is very much limited, especially in the case of low memory embedded systems. To provide a C library with minimal memory footprint suited for use with microcontrollers, ARM introduced NewLib Nano, which is based on NewLib. NewLib Nano is again a reduced feature version of NewLib. For example, NewLib Nano doesn't support float data type by default. For that, you have to send some extra compiler arguments. In this exercise, I will be using NewLib Nano. Let's locate the NewLib and NewLib Nano libraries. You have to go to the toolchain installation path, this path in your system, and here you will find a libc.a, that's the archive. This is a NewLib library, and this is NewLib Nano. Here you will also see a couple of other libraries like lbrdi mon.a. These are used during semi-hosting. These are semi-hosting library. I'll talk about semi-hosting a little later. And after that, you also find a couple of spec files like nano.spec, nosys.specs, pid.specs. These are some spec files which you are going to use during linking stage of your project to make your application link to these libraries. So I will show you that in a moment. Let's talk about some other things what we need to do for this project in order to link successfully with the C standard library. We should take care about low-level system calls. The idea of NewLib is to implement the hardware-independent parts of the standard C library and rely on a few low-level system calls that must be implemented with the target hardware in mind. That means NewLib doesn't provide low-level system calls which is going to operate on some of the hardware units of the microcontroller. You have to provide the low-level system calls. When you are using NewLib, you must implement the system calls appropriately to support devices, file system, and memory management. For example, let's say if your embedded application wants to use printf, we know that printf is a C standard library function. That standard library function is provided by the NewLib Nano or NewLib. Then NewLib calls the low-level system call, that is underscore write. Here the underscore write is a low-level system call that must be provided by you. What you do inside the write function depends on your hardware. You can write into the UART, or you can write into the LCD or to the ITM FIFO, or you can do whatever you want as per your board or target. What happens here is This is a kind of redirection. So the new lib redirects printf to the low-level write function. Write function implemented here will receive all the strings which are formatted by the printf. You will receive the formatted string here from the new lib, and then you have to take a call where you are going to print that string, whether you are going to send that to the UART or LCD or something like that you have to provide. That's why here write is called as a stub or low level target specific system call. Like that, you have to provide a lot of system call implementation like write, read, SBRK. This is called by the new lib when the embedded application executes malloc or dynamic memory management related APIs. Now we have to include all the system call implementation. Now what you have to do is, I have attached a file with this lecture. File name is syscalls.c. I want you to download that file and place it in your workspace. This file contains the function definition of some of the important system calls such as write, read, close, open, etc. This file doesn't contain complete implementation of all those system calls. Remember that what I said before, implementing a system call depends on your target. This file contains just a function definition, just to build our project without any errors. Also, just open that file and explore its contents. And in the next lecture, we are going to include that file in our build system, and we are going to compile our project with the standard C library. I'll see you in the next lecture.